Have you ever thought about a world where your phone charges just by you walking? Or where tiny sensors in a massive bridge power themselves for decades without a single battery change? It sounds like science fiction, but this future is closer than you think. Welcome to the incredible world of energy harvesting, where we're pulling power right out of thin air. For the longest time, we've been chained to batteries and wall sockets. From our smallest gadgets to our largest infrastructure, everything needs a constant supply of electricity. But batteries die, they need to be replaced, and they create a massive amount of waste. What if we could break free from that cycle? What if our devices could live and breathe on their own, powered by the very environment they exist in? Today, we're diving deep into the revolutionary technologies that are making this possible. We're going beyond solar and wind to explore the unseen energy that's all around us, just waiting to be tapped. We're talking about the kinetic energy from our movements, the heat energy radiating from our bodies and machines, and even the invisible radio waves filling our air. Let's start with something we all do every day: move. Every step you take, every vibration of a car on a highway, every sway of a tall building in the wind, that's all kinetic energy. Piezoelectric materials are the superstars here. These are amazing crystals that generate an electrical charge when they're squeezed or bent. Imagine integrating these materials into the soles of your shoes. With every footstep, you'd be generating a small amount of power, enough to trickle charge your fitness tracker or even your smartphone. Engineers are already experimenting with piezoelectric floors in busy train stations and airports. The footfalls of thousands of people could generate enough electricity to power the station, S-lights, or ticketing machines. It's not just about people either. Roads embedded with these materials could capture the energy from passing cars, powering streetlights and traffic signals along the way. We're turning everyday motion into a constant source of clean, renewable power. But what about when things are standing still? That's where thermal energy comes in. There's almost always a temperature difference between two things, and that difference is a potential power source. This is called the Seebeck effect. Thermoelectric generators, or TEGs, are devices that can convert a temperature gradient directly into electricity. Think about the heat your own body gives off. Smartwatches are being developed that use a TEG to harvest your body heat. The side of the watch touching your skin is warm, while the outer side is cooler. This tiny temperature difference is enough to generate a continuous supply of power, meaning you might never have to charge your watch again. The applications in industry are even bigger. Factories, data centers, and car engines all produce enormous amounts of waste heat. Normally, this heat just dissipates into the atmosphere. But by slapping on some thermoelectric generators, we can capture that waste heat and turn it back into useful electricity, improving efficiency and reducing the overall energy footprint. It's like recycling energy itself. Now, for the truly mind-bending one, harvesting energy from radio waves. We are swimming in an ocean of electromagnetic radiation. Wi-Fi signals, radio broadcasts, cell phone signals, they're all forms of energy zipping through the air around us. While the amount of energy in any one signal is tiny, special antennas called rectennas can capture these ambient radio frequency waves and convert them back into usable DC power. This technology is perfect for powering the countless tiny sensors that make up the Internet of Things, or IoT. Imagine a smart farm with thousands of soil moisture sensors scattered across the fields. Changing the batteries on all of them would be a logistical nightmare. But with RF energy harvesting, these sensors could be powered wirelessly and indefinitely by a central radio source, or even just by the ambient Wi-Fi signals that are already there. This means no batteries, no wires, and no maintenance. Just a seamless, self-sustaining network of smart devices. So what does this all mean for our future? It means a world with less waste and more sustainability. Billions of batteries are thrown away each year, leaching harmful chemicals into the environment. Energy harvesting offers a path to battery-less devices, significantly reducing our electronic waste. It also means unlocking new possibilities. We can place sensors in remote or inaccessible locations, like inside the concrete of a bridge to monitor its structural health, or even inside the human body for medical implants, all powered by their surroundings. These devices could operate for decades without ever needing to be touched. The engineering behind this is truly ingenious. It's about miniaturization, efficiency, and a deep understanding of physics. Scientists are creating new materials that are more efficient at converting vibrations into power. They're designing ultra-low power electronics that can operate on the trickles of energy harvested from the environment. Every microwatt counts. This isn't about replacing our massive power grids overnight. You won't be powering your house with your morning jog anytime soon. Instead, energy harvesting is about creating a symbiotic relationship between our technology and its environment. It's about making our devices smarter, more autonomous, and more sustainable, one tiny bit of harvested energy at a time. The next time you see a skyscraper swaying in the wind or feel the heat coming off your laptop, remember the hidden energy potential all around you. The quiet revolution of energy harvesting is already underway, building a future where our world powers itself. It's a future powered not by giant plants, but by the subtle, ever-present energy of our daily lives. Thanks so much for watching. If you're as excited about this technology as I am, hit that like button and subscribe for more deep dives into the science that's shaping our world. Let me know in the comments which energy harvesting tech you find most fascinating. See you in the next one.